This question says, write the stable ion for each of the following. So these molecules, atoms, like to gain or lose electrons so they can be like their nearest noble gas. So if you have fluorine, for example, I have to remember I can't put it in my pen. If you have fluorine, for example, it likes to gain an electron to be like neon. If you have oxygen, for example, it likes to gain 2 electrons to be like neon. And if you have nitrogen, for example, it likes to gain 3 electrons to be like neon. Said another way, the halogens, the 7A atoms, like to be -1 to be like a noble gas. Oxygen and sulfur like to be -2 to be like a noble gas. And nitrogen likes to be -3 to be like a noble gas. For the metals, it actually works exactly the opposite. Lithium would have to gain 1, 2, 3, 4, 5, 6, 7 electrons to be like a noble gas. That's not very possible because it only has 3 protons. So that's not going to be very stable if it has 7 extra electrons. So lithium would prefer to simply lose an electron to be like a noble gas. Then it'll be like helium. Beryllium, well, let's use magnesium as a better example. Magnesium would like to lose 2 electrons to be like a noble gas, neon, and aluminum would like to lose 1, 2, 3 electrons to be like neon. So 1A metals like to be +1, 2A +2, 3A +3, 5A -3, 6A -2, 7A -1. Now we can relatively straightforwardly answer this question. Write the stable ion for each of the following. Sulfur is in 6A, so it likes to be S2-. Magnesium is in 2A. Metals like to gain, lose electrons and get a positive charge, so it's 2+. This is an anion. This is a cation. Rubidium, which is right here, is in 1A, so it likes to lose an electron. We don't write +1, we just write plus. Bromine is a halogen, so it's in 7A. It likes to gain an electron. We just write minus, not -1. And aluminum is in 3A, so it likes to be 3+, like so.